In this design challenge, you are building an exoskeleton that you will wear and will detect a movement in your body by lighting up an LED.
The design challenge was to build a prototype that would light up an LED whenever a part of the body would move beyond a significant angle.
This design challenge is similar to the exoskeletons that human factors engineers like Emily study at Boeing to protect humans from repetitive motion or movements that might hurt themselves. In order for an exoskeleton to work, it will need to respond to your body's movement. In this challenge, we will use body motion sensing to light up an LED by using a special device called a potentiometer. Your prototype will need to detect a movement and light up an LED as a signal. Okay, so an important part of this exoskeleton design challenge is a sensor to help you detect different body motions. Let's ask Emily, what exactly is a potentiometer?
This is the knob that rotates, similar to a knob on a radio dial. And that's the knob that will control the electrical signal to the LED light.
Got it. When you turn the knob on the potentiometer, you are controlling the amount of electricity that goes through the wire, which will change the brightness of the LED. Now, what are the steps to get started?
So it's a multi-step project. First, build the circuit using the knob, and then figure out how to attach the knob to the body so that the circuit is stimulated when the body moves.
Great. What are some tips on where to put the exoskeleton?
So for your exoskeleton, you might want to look at various parts of the body that could move, that could be used to signal the sensor. It could be as simple as your neck movement, could be your arm, shoulder, wrist. These are different joints of the body, and the different joints are going to be the best place for you to think about where to attach your exoskeleton.
Let's see what exoskeleton prototype Emily made.
So this is a sample of the prototype that we built for the Exoskeleton Design Challenge. As you can see, there are two parts. There is the circuit board, which has the battery, the alligator clips, and this small LED, which lights up when the joint is rotated. The second part is the exoskeleton, which is attached to my arm. And you can see now that my elbow is bent, but at the corner where my elbow is the potentiometer. And the alligator clips signal that when the joint is rotated, then the light goes on.
Are you ready to engineer your own exoskeleton? Check out the activity on the Curiosity machine.